Hello, my dear future doctors. How are you? So, today we are going to discuss with a good concept electric field intensity due to an R. Correct? So, today we will calculate the value of electric field intensity at a point due to an R. What is that? You can see. If I will take an R, this is your R, having charge that is uniformly distributed. Now, if I want to find the electric field intensity at this point P due to this R having the charge, correct? You will find here, if I will join this one, we will consider it as radius for this R, correct? This point P, that is also will be considered as at a distance of R. Now we are going to find the value of electric field intensity at point P. For this one, let us suppose we are going to take the assumption there is a dq charge, right? I will consider this length as dl, having dq charges. So, due to this charge, if I am going to calculate the value for electric field intensity, and if I will integrate that one, then after that we can say that total value of electric field intensity due to that R is this one, correct? So first we will go with the concept, calculate the value for electric field intensity at this point P due to this charge D. Before going to that one, I am supposed to find that it will make a certain angle. Let this angle will be considered as theta, right? So overall theta will vary from this end to this end, right? So we will consider let this value. Whole angle should be considered due to an R is let it be alpha, then this value will become alpha by 2 and alpha by 2. We can say that theta will vary from alpha by 2 to alpha by 2. We will take this negative and positive as per the mathematical approach, anti-clockwise and clockwise direction. Now, we come to this point, what we will observe here. If I will find that due to this and R, electric field at this point P is in this direction, let it be dE. Now you will find this is making an angle theta, it is also an angle theta, correct? So if I will take the component of this dE, what we will observe here, this component will become dE cos theta, and due to this one more component you will get it, that is dE sin theta. Same fashion, if I will take the symmetrical charges concept, we will find that same dq at the same length. If it is going to be there, we will consider that again we will get a electric field intensity component in these two directions, dE sin theta and dE cos theta. So dE sin theta and dE sin theta will be cancelled out with each other because both directions are opposite to each other. So we will not go with that approach, we will take the approach for only this portion, and we are going to find the value for dE cos theta, right? We will take this only perpendicular, right? See here. So what we will observe here, if I want to calculate the value for dE cos theta, we can say that this value will become what? What is value for dE? We will consider k dq charge. Because dE we are considering a small value for dE only due to a small value of the charge, that is dq charges, right? dq k dq upon r square, distances is r, that way we will take r square cos theta, right? Now if I will consider this one, what will be the value for dq if this r having charge density, let it be lambda. So what we will consider, lambda into dl will be the total value of this charge. Consider this as equation 1, this as equation number 2. On substituting equation 1, equation 2 in equation 1, what we will get? We get d cos theta value will become equal to k dq upon r square cos theta. We can consider it as a k lambda dl upon r square cos theta. Correct? What is d cos theta? That you are going to calculate the value for dE only, right? This component is only d cos theta. So what we will observe here, again we have the next challenge is how to calculate the value for dl. So now you can apply the concept for plane angles. If it is theta, if it is r, if you are taking this as a small length dl, so what we can consider dl value will becomes r d theta, right? As per the plane angles concept, right? Theta value will becomes r upon radius. We have used this concept and we will get the value for dl. Now consider this as a equation number 3. This will become equation number 4. If I will substitute here equation number 4 in equation number 3, what we will observe here, we will find that d value will becomes equal to k lambda r d theta upon r square cos theta. Correct? So we will find it here. This value will becomes r k lambda upon r cos theta d theta. This value will becomes equal to d. Now, if I will substitute the integration in this one, we can calculate the value of total electric field intensity due to that arc. So we are taking integration on both sides. We will get it. E value will becomes equal to k lambda upon r integration of cos theta d theta. What is the limit? Limit already I have stated. You have to take alpha by 2 to minus alpha by 2. Okay. So electric field intensity value will becomes due to that r is equal to k lambda upon r integration of cos theta value will become sin theta. Substitute the limit. What we will get it? We will get it here. K lambda upon r sin alpha by 2 minus minus will becomes plus sin alpha by 2. So resultant that you will get it with respect to this arc, electric field intensity due to an arc at any point will becomes equal to E is equal to k lambda upon r sin alpha by 2 sin alpha by 2 will becomes 2 sin alpha by 2. This is your resultant of electric field intensity due to an arc. Correct? So this resultant we will use to find the various to solve the various numericals. Let us focus. Suppose if I am giving the example, or we can say that I will go with the cases of limiting case analysis or completing case analysis. In that one, if I want to go with the approach, we will find here same approach we will take it 2k lambda upon r sin alpha by 2. This is the electric field intensity due to an arc. Correct? Now if I am taking this example of semicircular arc, what you will get it, and I want to find the value for electric field intensity at point P. Now you can see here, if it is semicircular arc, what will be the value for alpha? That is my question. So we will find that alpha value will becomes pi. But this value is pi. So substituting the value of pi, you can find the electric field intensity at point P is equal to what? 2k lambda upon r. If it is the radius, sin pi by 2. Value will becomes what? 2k lambda upon r sin pi by 2 sin 90. That's value is 1. This will be your answer at electric field intensity due to semicircular arc. Right? Same fashion. Next important thing, what will be its direction? Since we are taking it as a positive charges on this arc, so electric field intensity direction will be radially out of it. If I will focus on the second question, what we will observe, this is also an arc. What is the value for alpha? Alpha value is this time pi by 2. This is 90. If I will take this positive charge, right? What we will get the value? If I want to calculate the value for electric field intensity at point P, we can use that resultant value. What we will observe? 2k lambda upon r sine pi by 4, and sine pi by 4 is what? Sine 45. So value will become k lambda upon r 1 by root 2. Value will becomes root 2 k lambda upon r. Now, thing is that we have gone through this resultant, we have got through this approach to solve this type of numericals. If they will ask in need, but they will ask if they will ask such type of, suppose if I am taking another one, right? This is the next problems you will find. You have to find the value for electric field intensity at point O. How we will find it? What we will observe here? We will observe here just now we have calculated the electric field intensity due to this and semicircular arc, and again due to this and R. We can also use this concept. We can write it E at O should be equal to E at O due to semicircular arc, right? Or plus E due to water arc, right? Like that. Otherwise, you need to find the value for alpha. What you will observe value for alpha here? Here it is pi. Where this is pi by 2. So value will becomes what? Pi plus pi by 2. Value will becomes 3 pi by 2. Either you use this concept, either you can use this one in your resultant, and you will get the electric field intensity at point O will becomes what? 2k lambda upon r sine 3 pi by 4. Now substitute the value for sine 3 pi by 4. Value will becomes 135. So again you will get the same answer, k lambda upon r. That's it. So this type of problems now you have to solve this one, and if the question will comes by mixing of finite line charges and an arc, you have to solve the same type of question in the next one. Okay, thank you. We will see you in the next one. Here what we will observe, the value will becomes 2k lambda upon r sine 3 pi by 4. We can write it as a pi minus pi by 4, right? And this will comes in second quadrant. So what will be the value? 2k lambda upon r sine pi by 4 itself. So value will becomes final value. What you will observe at electric field intensity at O is 2k lambda upon r sine pi by 4 is 1 by root 2. Value will becomes root 2 k lambda upon r. Correct? So this type of question you will get it, and you have to be answered from their resultant or their limiting case analysis. Next thing is that if they will ask about the direction of electric field lines, what you will observe? This is all are positive charges. So its direction will become radially outward. This will be the direction for electric field lines. Okay. Similarly, if I will focus on the second type of question, see, suppose if I am taking this one, this is R having positive charges, this R having negative charges. I want to calculate the value for electric field intensity at this point O. How we will calculate it? This type of problems we will get it. So what you have to see, due to this R, let electric field direction is E. Let it be E1. Okay, radially outward. Due to this one, it will become radially inward. So what will be the net resultant electric field? This will become the net resultant electric field. Got it? So first for this R we will calculate the value for E1. Again we will calculate the value for E2. Let it be E2. And then we will calculate the value for E2. So this type of problems will comes, and if you will find this type of problems, you can solve easily with the limiting case analysis of the R. Right? Same problems can be mixed with the finite line charges, infinite line charges, and we will focus on that in the next one. Okay, thank you. We will see you next class.